Welcome to Biology of Marine Mammals. I'm Dr. Leslie Williams, and this is the first of 2 lectures covering the evolution and characteristics of the Odontocetes. We'll start by first going through the characteristics of the toothed whales, a quick review that will bring us back up to speed on what the Odontocetes actually represent. Then we'll start looking at some of the groupings, including the Delphinidae, a family of true oceanic dolphins, the Phocinidae, a family of porpoises, and the Ziphidae, a family of beaked whales. The word Odontocete has the word dont, D-O-N-T, as a root, and dont means tooth. So all Odontocetes have teeth, and this is what makes them distinct from the Mysticetes, which have baleen. There are 70 or over 70 recognized species, and currently they are grouped into 10 families. While taxonomically we really should cover them as 10 distinct families, it's more convenient to actually group them together as 6 groups. 5 of those groups are going to be monophyletic, that is, each group really represents a distinct family. But the last group, the river dolphins, are paraphyletic, and their grouping is one of convenience. So not all the groups that we talk about will be monophyletic. Before we actually get into the taxonomy and organization of the Odontocetes, let's actually review some of their defining features. As we stated earlier, all Odontocetes have teeth. The word dont means teeth. So all Odontocetes species possess teeth, though truthfully they're not always visible. Moreover, all Odontocetes are homodonts, where each species possesses only one type of tooth. So what I'm going to do is go over to this camera and we'll take a look at our bottlenose dolphin skull here, and we'll actually see the one type of tooth and what we're referring to here. So in this picture you can see that all the teeth that this Odontocete possesses are all the same. They're all conical. They all look like cones. That's different than our skulls. If you take a quick look in the mirror, you'll see that your own teeth actually have different shapes, which of course makes you a heterodont. And then even the pinnipeds are different. This right here is the lower jaw of a pinniped, and you can see from the camera that the teeth are a little bit different looking. The ones at the tip of the jaw are different than the ones farther back, so that makes them a heterodont. So all Odontocetes are going to be homodonts. In other words, they all have the one type of tooth. Okay, another defining feature is that they have an asymmetrical skull, which is a little difficult to see from a gross perspective, but if we put it up under the camera, you might be able to see a little bit more here. This is a top-down view of the bottlenose dolphin, and from this view here you can see that the nasal cavities, which are here and here, are slightly differently shaped, and even more pronounced is going to be the different flares from here to here. So if you take a good look, you can see that this line, which looks like it should run down the middle, curves a little bit, and this side is shorter than this side. That asymmetry where you see the skull is actually slanted a little bit enhances echolocation, which is also a feature of the Odontocetes. We'll go ahead and put this guy back here and continue with our lecture. As I stated earlier, there are 10 families that comprise the Odontocetes, but it's convenient to look at them as 6 groups. So the groups that we're going to look at today are true families. We're going to look at the true oceanic dolphins, we'll look at the porpoises, and finally we'll look at the beaked whales. The sperm whale, river dolphins, and beluga and narwhals will be saved for the second part of this lecture. Let's start with the family Delphinidae. The Delphinidae, or dolphins, are what most people think of when they think of an Odontocete or a toothed whale. So the Delphinidae represent what most people think of again as a common dolphin, and they include everything from the bottlenose dolphin, the common dolphins, the spinner dolphin, to the larger orcas. So when people think of Odontocetes, they're almost always thinking of family Delphinidae. The family Delphinidae evolved 11 to 12 million years ago, and there are between 33 and 38 recognized species, and they have a very typical dolphin body shape. So when you say dolphin, again, you're probably thinking Delphinidae. Moreover, they have conical teeth, as we saw earlier with the bottlenose dolphin skull. That is, all of their teeth are cone-shaped. They also have very pronounced asymmetry, which we also saw, where we saw that the skull was actually shifted a little bit, and that allows them to have very precise and enhanced echolocation. Echolocation as a process will be discussed in a later lecture. And finally, something that you might have noticed from the pictures is that they have different colors. And of course, nobody defines this better than the orcas, which are black on top and white on the bottom. And that technique or that concept is called counter shading. So that's a common color scheme that we see for animals in the water that are trying to achieve one of two things, or possibly both. One, avoid being seen by predators, and two, avoid being seen by your prey. So this is how counter shading works. If you're dark on the top and you're swimming underneath something, either a predator or your prey that you're trying to sneak up on, the water is dark. So when prey or predators look down, hopefully your dark skin is going to blend in with that dark, deep water. Conversely, if you are swimming underneath and you look up, you're going to see sunlight. So it's going to be very light above. And hopefully the lighter bellies are going to allow that species to blend in. To show just how important this is, some species of Delphinidae will actually swim underneath their prey and then flip over, exposing their light-colored bellies, which freak out the fish, which all then swim to the surface, and then they try to gulp them in one big feeding frenzy. So they actually use this technique to their advantage when they want to be seen by flipping over. Okay, let's move on to the Phocidae, or the porpoises. The family Phocinidae includes 6 species of porpoise, and porpoises are defined by actually having a different shaped tooth. So if you ever pull out a species and you're not sure if it's a Delphinidae or a porpoise, you just have to look at the teeth to tell. If it's a conical tooth, then it's a Delphinidae, and if it's what's called a spatulate tooth, then it is a porpoise. I'm going to go back over here and draw that for you so you can clearly see the difference in the teeth. We already took a look at the bottlenose dolphin, which is a member of the Delphinidae, and we noted that its teeth were cone-shaped or conical, like so. The porpoises have what are called a spatulate tooth, and it looks like a flattened spade, and it has more of this shape to it, like so. So this shaped tooth is a spatulate tooth, and it defines a porpoise. This one is a conical tooth, which is characteristic of the Delphinidae. Of the 6 existing species, 3 of them live in the northern hemisphere, including the harbor porpoise, Dall's porpoise, and the very critically endangered vaquita. When you take a look at the body plan of a porpoise, there are some noticeable differences from the Delphinidae, including the fact that they have a rather stocky body, so they tend to look a little bit squatter. They also have a reduced rostrum, which is clearly visible in these pictures. You notice there's no pronounced beak there. And finally, they're quite small. Most porpoises are smaller than a human, and the largest porpoise measured is about 2.5 meters, which is equivalent to the size of a very, very tall human. So all porpoises are pretty small. Moreover, they exhibit a rather interesting reproductive cycle. They tend to hit sexual maturity really early as 3 years old. That's very early for a mammal of this size. And moreover, they have a shorter lifespan. So because of this, porpoises are often considered to take on a juvenile state. That is, they don't live very long, they tend to look like juvenile dolphins, and they also reach sexual maturity very early. Now, I mentioned the vaquita, which is probably the most critically endangered cetacean right now since the Chinese river dolphin recently went extinct. The vaquita are actually locked into a very small area in the Gulf of Mexico, and they're endemic to that area and they can't get out. Unfortunately, that area is also a prime fishing spot where fishermen set up gill nets to catch certain types of sea bass and other fish. These vaquitas, or very small porpoises, end up getting caught accidentally in these nets and drowning. Consequently, somewhere between 35 and 80 are removed through this accidental capture method each year. That's very tragic considering that the population is already small. In 1997, a population survey estimated that the number of vaquitas was around 567, and just 10 years later, in 2008, the population was expected to be only 40% of that at 245. Without some type of conservation intervention, probably in the form of reduced fishing, these guys are going to go extinct sometime soon, which is tragic. That makes them the most critically endangered cetacean on our planet as of 2011. And finally, let's move on to the elusive Ziphidae, or the beaked whales. If you look at these pictures, you'll notice I have two carcasses from a stranding, and that's because the Ziphidae are rarely encountered, so most of what we know about them actually comes from individuals that have stranded themselves. You might also notice from this picture that the Ziphidae are quite large compared to a human. Because of this, species are also called whales because of their large size, but remember that they are still Odontocetes. They are not baleen whales. So let's take a closer look at these Ziphidae, or beaked whales. Of course, the name implies that they have a beak, or a very pronounced rostrum, which is clearly evident from the picture. You can see a very long beak there. Of course, they also tend to be larger. 20 feet isn't uncommon. And they also tend to be one of the more prolific families. In fact, past the Delphinidae, they are the second most common family with over 20 identified species. But that's probably an underestimate because they are so rarely encountered. There are probably some species that we have not identified yet. So there's probably more than 20. In fact, they are rarely encountered because they're not coastal. They tend to be way out in the ocean and deep divers, which means that they don't stay at the surface for long periods of time. Most of what we know about the Ziphidae comes from stranded individuals. The Ziphidae have a really interesting apomorphy in their tooth pattern. In fact, if you take a good look at many of the individuals of the Ziphidae, you'll notice there are not any teeth at all. So how could they possibly be Odontocetes if they lack a tooth? Well, the answer is that not all individuals show teeth, but the adult males do. And the adult males actually show a very interesting tooth pattern. They only have one or possibly two pairs of teeth. These teeth erupt from the lower jaw, as clearly evident in this picture of the skull. So you have two rather large teeth that erupt from the lower jaw only in adult males, but not in females and not in juveniles. So in the stranded individual that's shown in the upper right-hand corner, we're going to guess that that's either a female or a juvenile based on the lack of teeth that are seen in that beak. So what are the teeth used for? Well, since females and juveniles clearly survive and obviously thrive without them, they're probably not used for feeding like most teeth are. So we postulate that they're probably used for some type of intraspecies aggression, where the males are fighting the other males with their teeth, probably for access to females to mate with. Indeed, they are suction feeders. So by suction feeding, they actually just suck up their prey and they don't need their teeth to actually grab their prey. So the teeth probably aren't necessary for life, but are retained in the males due to intraspecific aggression. And with that, I'll see you next time.